Hello and welcome. In this video, we will calculate reluctance for the iron core here in gray color. This is a simple 3D design for a U-shape rectangular core. We have here a permanent magnet. This is a cube permanent magnet. The direction north, the north direction for the cube magnet is in the positive direction for the z-axis. So flux directly goes from north to south pole like this here. So let's start by reluctance definition. Reluctance is the magnetic equivalent of electrical resistance, and it measures how much a material or magnetic path opposes the magnetic flux. It is similar to electric resistance in electrical circuits, but it's actually the resistance for the magnetic flux. Actually, magnetic motive force is equal to number of turns multiplied by the current value. We don't have here a coil, so we will depend on the next term. Magnetic force is also equal to flux multiplied by the reluctance and the magnetic field intensity multiplied by the length of the iron core. So we can conclude that reluctance is equal to magnetic field intensity multiplied by length of the core and divided by the flux. And actually flux is equal to magnetic field density multiplied by the cross-sectional area of the iron core. So we will depend on this relation to calculate the reluctance value for the iron core. Also, you can find at this link here. I will leave the link under this video, so you can get back to or refer to this link. This link actually is a tutorial from Ansys Innovation Space Lab to calculate the reluctance, but for 2D design. And it depends on the same magnetomotive force relation to calculate the reluctance. The difference here is that we calculate the reluctance for a 3D design. So for our design, I defined a line exactly in the center of the iron core here. And also I defined a cross-sectional area at the center of this core as shown here and perpendicular to the line. So what we will do here is that we will go to the field calculator here, and first we will select H, which is the magnetic field intensity, and choose the line here, and click here on vector. We will click on tangent and integrate this value and save it to a parameter called HDL. After that, we will select from here magnetic field density, and for the geometry, we can select the rectangle 2 here. We click OK, and on vector, click on normal, and then integrate, and add this to a parameter called BDA. And to calculate reluctance, we need to divide HDL by BDA. So we can copy this here and also this, and divide the result to get the reluctance. So I will add this to a variable called reluctance, and click here OK. And now to show these results, we need to go to results and create field report, and click here on data table and select all these 3 parameters and click here new report. Okay, so we can see here that the reluctance value is shown here, and it has a negative sign. Actually, this negative sign just indicates the direction of the flux, So we can neglect it, and this is the reluctance value for the iron core. So I hope this video will be useful for you in reluctance calculation related to 3D design, and see you in next videos.